Howdy and welcome back. So we just spoke briefly about expressions and now we're on to operators. And you'll see why I'm spending time going through this. A lot of what will be covered here, you've probably encountered. You might think about it subconsciously as you're forming your expressions. But nonetheless, I think it's important to take the time to just go through and remind you of some of this stuff. So just a couple basic concepts here. Unary operators are going to act on one operand. An example of this might be -7, where the operator is simply signifying that its operand is a negative integer value. Binary operators act on two operands. For instance, plus, we're adding two integer values together. Some tokens are used as both unary and binary operators. For instance, -7 to signify a negative integer value, and then subtraction with 8 minus 7 would be another example of this. There's also a ternary operator in C++, and let's just take a look at this very basic conditional. If A is true, X equals B, else X is equal to C. So, I mean, that seems like kind of a lot to write out, and there's kind of a shorthand notation for these sorts of simple if statements. If we write something like X is equal to A question mark B colon C, this is the ternary operator, also known as the conditional operator in C++. It has essentially three components to it. The first is going to be the conditional that is going to be analyzed. If that conditional evaluates to true, that is going to be the result of the expression, B. And what comes after the colon is going to be if false. So in this case, if A evaluates to true, X will be assigned the value stored in B. Otherwise, X will receive the value stored in C. And we'll get into a little bit more about this here shortly when we consider some other features of expressions that more or less have kind of a lot more going on. So this is where I'm going with it. Grouping operators and operands. Again, for the arithmetic types, I mean, it's very likely you'll recall this from grade school. It's so ingrained that you think about it subconsciously. But we're just going to bring that into your conscious to just remind you of how some of this works, so you're cognizant of it as you're composing your expressions in our programming language. So an expression with two or more operators is going to be called a compound expression. To understand how these expressions are evaluated requires an understanding of precedence, associativity, and the order of evaluation. The last one's a little tricky, but I think it'll be clear with the example we have. It's just, I guess tricky is the wrong word. It's kind of strange. We'll go with that and continue through. But let's start with precedence here. So operands of operators with a higher precedence group will group more tightly than those at lower precedence. Multiplication and division both have higher precedence than addition and subtraction. This means that multiplication and division groups before operands to addition and subtraction. And I mean, if you just look at the next example, it's very intuitive. It's, you can do this in your sleep. 3 plus 4 multiplied by 5 is going to evaluate to 23 because the multiplication in that expression will be carried out first to evaluate to 20, and then 3 will be added to that result, not 35, which we would have arrived at if we added 3 to 4 first and then multiplied that result by 5. So precedence deals with, okay, what gets evaluated first? Associativity does the same, but it's within the actual groups of operators that have the same precedent. So associativity determines how operators of the same precedence are grouped. The assignment operator is going to be right associative, which means operators at the same precedence level are going to group from right to left. This allows us to write assignment statements such as follow. Let's introduce ival and initialize it with 0. Let's introduce jval, initialize it with 1. This statement here is assignment, and it is right to left associative, meaning we're going to start here. We have 5. 5 is going to be put into JVal. So at this point, JValue will take on the value of 5. Then the value stored in JVal, now 5, will be used to assign to I value. And at the end of this, I value gets 5. Had assignment been left to right associative, we would have had I value is equal to J value. So it would have been I value gets 1 and then J value gets 5. That's not the case here. Assignment will always be right to left associative. Now, arithmetic operators, on the other hand, are going to be left associative, which means operators at the same precedence group, left to right. So looking at this here, we'd first carry out 20 minus 15 to get 5. And then from 5, we'd go ahead and subtract 3 to arrive at 2. Had this been right to left associative, 15 minus 3 would have given us 12. 20 minus 12 wouldn't have given us 8. But this is not the case. As far as associativity goes, it's going to be for arithmetic operators, left associative. Now here's the kind of strange one, because this is left up to the implementation to define. So precedence is going to specify how the operands are grouped together. It does not specify the order in which the operands are evaluated. In most cases, the order is largely unspecified. For example, in this very simple declaration, I is going to be initialized with f of 1 multiplied by f of 2. These are both function calls. I'm sure you've seen them in your previous programming course. We haven't introduced them just yet, how we declare and define them in C++, but that's coming up soon. In fact, I believe that's the next lesson. But anyways, looking at this expression, it's, we know that multiplication is going to be conducted first here, and then the result of that's going to be used to initialize I. Great. However, it's unknown whether f of 1 will be called first or if f of 2 will be called first. And why this matters is think about maybe two functions that might mutate the same variable within the same statement. That's going to be problematic because the order in which they're evaluated is going to be undefined. And therefore, if we're expecting the dependencies to occur in one order, it's not guaranteed to happen in that order. So in these scenarios, it's always kind of best to just go and let's call it J is equal to F1, assuming that we want F1 to be called first, and K equals F of 2, and then go int of I is equal to J times K. And again, this is under the assumption that F1 and F2 are somehow dependent on one another and are somehow interacting with the same data that could prove problematic if the order of evaluation is changed. So let's go ahead and just look at the arithmetic operators and their precedence, and then also point out or just remind you that they're left associative. So this is going to go from low to high precedence. We'll see here that the unary plus and unary minus are going to be of the highest precedence for the arithmetic operators. And they're one group together, so they have the same level. We'll then look at our next grouping, multiplication, division, and modulo. These are below those unary operators, but those within this green box are of all the same precedence level. So associativity would determine which one is evaluated first. And then at the low end, we have addition and subtraction. In this case, those would be evaluated last, and again, addition and subtraction, because they're both in the purple box here, they're going to have the same precedence level. Now in C++, we also have the ability to carry out logical and relational expressions. We'll see here that, again, going from low to high, the highest precedence here is going to be logical not. I'll go ahead and put it in purple. The next grouping that we frequently will encounter in our programs is going to be most of the relational operators here. So less than or equal to, greater than or equal. They're all of the same precedence. So associativity would determine the order of evaluation here, and all of these are left associative. Finally, at the lower end of our common operators that we're looking at here, I'll put them in green. We have equality and inequality, both left associative. And then finally, the last group at the lowest end is going to be logical and logical or.